Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
pH has a wide variety of applications in industries, because in industries various solutions are used. So we want to find out that whether the solution is acidic in nature or alkaline in nature. It is essential because when we know about the acidity or alkalinity of the solution, then a chemical process can be proceeded effectively and efficiently. So it is very necessary in the industries to find out the pH of the solutions. So measurement of pH has a wide variety of applications in the industries, which are mainly related with the water and wastewater treatment. So industries which are related with the water and the wastewater treatment. Mainly there the measurement of pH is having a application of it. So measurement of pH is necessary to find out the alkalinity or acidity of a solution, that whether the solution is acidic in nature or alkaline in nature. So if we want to define the pH, then we can say that pH is a measure of the acidity or alkalinity of the aqueous solutions. Aqueous solutions are those solutions which are being dilated or dissolved in water, okay, which are having the water as their solvent. So if we say that alkalinity or acidity, we want to find out that whether the solution or the chemical is an acid or it's a base. So what are acids and bases? Acids are those which when react with water, they are going to produce the hydrogen ions, and bases are those which when dissolved with water, they are going to produce the hydroxyl ions. So we can define the acids and bases as acids are those substances which dissociate. Dissociate means they are going to break or split. Okay, so acids are going to split and they are going to form the or produce the hydrogen ions, or we can say that when they react with water, they produce hydrogen ions, whereas bases are those substances which dissociate to produce the hydroxyl ions. Okay, so if in the form of reaction we describe acid and bases, then acid is, suppose Ha is an acid, so it is going to dissociate and produce hydrogen ions plus an ion. Okay, an ion is having a negative charge over it. Okay, and this is the hydrogen ion. Now bases, suppose that MOH, it is a base, so it is going to dissociate into a cation plus hydroxyl ions. So this is an acid, this is hydrogen ion, This is anion, this is cation, and this is hydroxyl ions. So acids produce hydrogen ion and bases produce hydroxyl ions. So if we want to find out that whether the solution is acidic or it is basic in nature, okay, so if the hydrogen ion concentration is more, it means that it is acidic in nature. If the hydroxyl ion concentration is more, it means that the solution is basic in nature. So to find out the pH, we are going to either measure the hydrogen ion concentration or we can measure the hydroxyl ion concentration. So if a solution is acidic solution, then it will have more concentration of hydrogen ions, that is H plus ion. And if it is a basic solution, then it is going to have more concentration of hydroxyl ions. Okay. Now in water, we know that water is H2O. Okay. So in water, if we are having the aqueous solution, then the molar concentration of the hydrogen and the hydroxyl ions, it is equal to the dissociation constant. So in the aqueous solutions, we can say that the product of the hydrogen ions and the hydroxyl ions, their product of molar concentration of these ions is equal to the dissociation constant. So H plus ions, their product with the hydroxyl ions is equal to the dissociation constant, which is represented as Kw, because this is the dissociation constant of water, and the value of this constant at 25 degrees Celsius of temperature is 10 raised to the power minus 14. Okay, so this is the dissociation constant of water at 25 degrees Celsius. Now, as I have said that if we want to find out the pH of a solution, or if we want to find out that whether the solution is acid or a base, then we can find out it with the help of the concentration of either the hydrogen ions or the hydroxyl ions. Okay. So we can define pH as So pH of a solution is defined as the negative logarithm of the hydrogen ion concentration. Okay, and if we write it in the mathematical form, then pH is given as negative log to the base 10, and here hydrogen ion concentration. Okay, so with the help of the hydrogen ion concentration, we can find out the pH of a solution. Now this hydrogen ion concentration, it is measured on a scale which is known as the pH scale. And the value of this scale, or the range of this scale, is from 0 to 14. Okay, so from 0 to 14 we have the different values of pH for the solutions. So let's see that how the pH can be calculated. Suppose that in a solution we are having the hydrogen ion concentration as 10 raised to the power minus 14. So we are going to put its value in the formula, minus log to the base 10, and here we are having 10 raised to the power minus 14. So pH is coming out to be 14. So the pH of that solution is 14. Okay. Now suppose that because this is the hydrogen ion concentration 10 raised to the power minus 14, and we know that dissociation constant at equilibrium is also 10 raised to the power minus 14. That is the product of H plus ions and the hydroxyl ions. It has to be 10 raised to the power minus 14. So if hydrogen ion concentration is 10 raised to the power 14 and OH ion concentration we want to find out, equating it with 10 raised to the power minus 14. So hydroxyl ions concentration will be 10 raised to the power 0. Okay. So in that solution, if the hydrogen ion concentration is 10 raised to the power minus 14, then hydroxyl ion concentration will be 10 raised to the power 0, and the solution is having the pH value as 14. Okay. Now this pH scale, it is being divided into 3 parts. One is the acidic range, then we have the neutral range, and then we have the basic range. Okay, means acidic range means the solutions, if they are having the pH value in that range, then those solutions are the acidic solution. If it is having pH value as 7, then it will be a neutral solution, and if it is having the pH value greater than 7, then it is an basic in nature. So we can define this scale as so neutral solution like water, they will have pH value equal to 7. The solutions which are having pH value greater than 7 are the alkaline solutions or the solutions basic in nature. Okay, they are called the base, and the pH value is, if it is between 0 to 7, then the solutions are acidic. So if this is the range, this is pH value 7, this is 0, and this is 14. So pH value is 7 means a neutral solution. pH value from 0 to 7, it means it is an acid, and from 7 to 14 it is called a base. So this is how the pH is going, it is a measure of the acidity or the alkalinity of a solution, and it can be measured with the help of measuring the hydrogen ion concentration in the solution by using that formula, pH is equals to negative of log to the base 10 and the hydrogen ion concentration. Suppose that a solution is having the hydrogen ion concentration as 10 raised to the power minus 12. So if we want to find out its pH, then pH is equals to negative of log to the base 10 and hydrogen ion concentration. So here pH is equals to minus of log to the base 10, and this is 10 raised to the power minus 12. So pH is coming out to be 12. Now if we see the pH scale, then if the pH is greater than 7, then this solution is a base. So with the help of this pH value, we can find out that this solution is a base. Okay. And if we want to find out the concentration of the hydroxyl ions, then we know that H plus OH minus is equal to 10 raised to the power minus 14. If H plus is 10 raised to the power minus 12, then OH minus will be 10 raised to the power minus 2. Okay. Then it will be equal to 10 raised to the power minus 14. So hydroxyl ions concentration will be 10 raised to the power minus 2. Okay. So from this we can conclude that the pH value can be measured by measuring the hydrogen ion concentration, and this pH value, it is measured on a scale, and this scale is having the range from 0 to 14. Okay. Now as the pH value starts increasing, means it starts increasing from 0 to in the direction of 14, then the solution become basic in nature, and if the pH value starts decreasing, then the solution becomes acidic in nature. So this was the measurement of the pH by measuring the hydrogen ion concentration. Now there are various methods in which the pH can be measured by the electrical methods. In that method, a pair of electrodes is immersed in that solution. This pair of electrodes means two electrodes are there. One electrode is called the measuring electrode and the other electrode is called the reference electrode. So with the help of those pairs of electrodes, we can measure the pH of the solution. Let's see that method. So measurement of pH can be done by using a pair of electrodes, means two electrodes are there. One electrode is called the reference electrode and other electrode is called the measuring electrode. And we are going to immerse those pair of electrodes in the solution whose pH we want to measure, and then we are going to measure the voltage which is produced across the two electrodes. Okay, so with the help of voltmeter we are going to measure the voltage. Okay, and that voltage is going to give us a measure of the pH of the solution. So as I have said that there are two electrodes. One is the measuring electrode and other is the reference electrode. So this reference electrode, it is taken as a reference, so this is kept at a constant voltage. Okay, regardless of the pH of the solution, which solution we have used. So reference electrode is kept at a constant voltage, whereas the potential of the electrode, measuring electrode, we are going to measure it with the help of the voltmeter. So because the reference electrode is having the constant voltage irrespective of the pH of the solution, and measuring electrode, its voltage is being changing. So there will be a potential difference between the two electrodes, and this potential difference depends upon the pH value of the solution under test. So let's see the construction of the measuring electrode and the reference electrode, that of which material they are made up of, and let's see the arrangement of this measurement of pH. So these are the two electrodes which are used for the measurement of the pH. One is the reference electrode, another is the measuring electrode. So this reference electrode, it is made up of glass, okay, and in this glass tube we are having an inner assembly. In this inner assembly you can see that in this part the fluid is filled, and this fluid is the calomel and mercury. Calomel is a solution of the mercury chloride. So mercury chloride and this mercury is filled in this much part in both the reference and the measuring electrode. Okay, in this portion is being dipped, and here the electrode leads are being connected. Now this was the inner tube. Okay, in the reference electrode we are having a cotton plug here. Okay, so that this fluid cannot come outside this the inner solution cannot come in the outer solution. Okay, the two solution cannot mix with each other, so here we are having cotton plug. Then the outer solution in the reference electrode is the KCl, that is potassium chloride, whereas in the measuring electrode it is a buffer solution. Okay, so KCl is having a constant pH. Also in this reference electrode, at the bottom of this tube we are having a small opening which is called the liquid diffusion opening, so that this KCl solution can drop by drop, it can come out of this reference electrode, and when this reference electrode is dipped into the solution whose pH we want to measure, so this KCl solution can come in contact with the solution which we want to measure. Whereas in this measuring electrode, the bottom tip it is closed, okay, and this tip it acts as the pH sensitive tip. So when this measuring electrode comes in contact with the solution, or it is immersed in that solution whose pH we want to measure, so buffer solution and that pH solution, because buffer is also having the pH value, constant pH is there, and the liquid whose pH we want to measure, so when they are coming in contact with each other, then a voltage will be generated, and that voltage can be measured with the help of this electrode and with the help of the voltmeter. So both these electrodes, reference and measuring electrode, they are dipped in the solution whose pH we want to measure. And this KCl solution, when it comes in contact with that solution, here also we because KCl is having a constant pH value, so a constant voltage will be generated here, and here some other voltage will be generated that can be measured with the help of the voltmeter. So if we see the working of this method, so reference electrode, because it is having a small opening there, so here, so in the reference electrode we are having a small opening here, so this KCl solution will come out of it and it will be in contact with the solution whose pH we want to measure. So here a constant voltage is generated, and because here this buffer solution in calomel and mercury, because it cannot come out of it, so only they are in contact with each other, okay, and this tip, because it is having no opening here, so it will not act as a diffusion opening, but it will act as a pH sensitive tip. So the voltage which is generated, it will depend upon the pH of the solution. So potential generated at tip. So the potential generated at the tip depends on the pH of the solution. And this potential can be measured with the help of the voltmeter. So this voltmeter can be calibrated to give us the readings of the potential, or we can calibrate it to give the readings of the pH value of the solution directly. Okay. So this complete assembly of the reference electrode and the measuring electrode, both these pair of electrodes, they are dipped into the beaker or container which is having the solution whose pH we want to measure. Reference electrode, it is kept at a constant potential because here constant pH is there. Okay, so constant voltage will be generated here, but here when the measuring electrode, there will be a potential difference which is generated at this pH sensitive tip, and that potential difference can be measured to give us the value of the pH of the solution. So this is the method with the help of which we can measure the pH of the solutions in the industries, and this is called the pH meter. There is another method which is called the litmus paper method, which is used to measure the pH of the solution, or we can say that it gives us an indication that whether the solution is an acid or a base. So if it is an acid, so it is going to change the blue litmus paper to red. Okay, so if the blue litmus paper is changed to red, then it will be an acid, and if the inverse of this happens, then it is a base. So with the help of litmus paper or with the help of this strips, we can also find out the pH, or we can also find out that the solution is either the acid or the base. So these are the methods with the help of which the pH is being measured. Let's see its advantages and disadvantages. The advantages of the pH meter used for measurement of pH is that it is very simple to use. With the help of finding the hydrogen ion concentration and by measuring the potential, we can measure the pH of the solution. Also, it's very portable, its cost is very low, and it can be shifted from one place to another. So it's a portable device, simple to use, calibration controls are also there. So these are the advantages of the pH meter. Now if we talk about its disadvantages, then in this method we saw that the reference and the measuring electrodes, they are made up of glass. So while handling this instrument, care has to be taken so that the glass is not broken up. Okay, also cleaning is to be done from time to time so that it cannot get contaminated by the solutions. Also, we have to take care that if we want to measure the pH of the solutions which are corrosive in nature, then such fluids are also going to damage the instrument. Okay. Also, temperature measurements, temperature and pressure changes, they are also going to affect the readings. So environmental factors also we have to check here. So these are the advantages and disadvantages of the pH meters which are used for the measurement of pH of a solution. If we talk about its applications, I have already told that in the industries like the water treatment and wastewater treatment industries, where we want to find out that whether the solution is alkaline in nature or acidic in nature, in those industries the pH measurement is having its wide applications. So these were the applications of the pH measurement method. So in this video, we studied about the measurement of pH. We studied that what is pH, how it can be measured, and how the value of pH varies for the acids and the bases. Then we saw the measurement of the pH by using the electrical method, that is reference electrode and the measuring electrode method. Then we saw the litmus paper method also, which is used for measurement of pH. In the last, we saw the advantages, disadvantages and applications of the measurement of pH. So I hope that this topic is now clear to you. Thank you.